Hello students, today I am going to start a new topic, statistics, that is chapter 14. In this video, I will teach you the basic terms in statistics, formulas to find mean, median and mode of both the discrete and continuous frequency distribution. Let us start.
Statistics is very simple topic. Okay, everybody can easily score mark and they can improve their percentage of mark in this subject. Okay, so the very basic terms in statistics, that is data, frequency, tally mark, frequency distribution, everything everybody knows. So I am just starting with this basic level and we will discuss finally the very important topics which we are going to deal with in this lesson. Okay, so first, what is data? Data is nothing but the collected information or the numerical facts collected is what we call data. Okay, so we can represent this data in different ways. Okay, in the first case I will take a very simple example and we can represent that data, how this can be done. Okay, see, suppose I am collecting the marks scored by a student in an examination, okay, in 5 different subjects, that is in English, okay, out of 50 marks. So 43, then Hindi 42, mathematics 45, science 49 and SS 40. Okay, that means I collected marks scored by a student in an examination. Okay, see, in this data, each mark is what we call observation. Observation. Okay, this is very basic level of representing a data. In some cases, what is the second method, second way, that is, suppose I am collecting marks scored by a whole class in a particular subject. We can take the marks scored by 10A. Okay, in mathematics, suppose in that class, okay, there are 40 students. Okay, out of 50 marks, okay, out of 50, see, there may be 6 students scored 50 marks, full mark. Okay, and sometimes there are 7 students who scored mark 25. Okay, this way also we can represent, and there may be 12 students who scored mark 37. Okay, and there are 5 students who scored 15 marks. This table also shows some marks, that is the numerical facts. Okay, that is, this is also a data, this is another way of representing data. But here you can see one more column. Okay, here in the first column, okay, I have written the marks, and the second column, number of students. Okay, so and this second column, that is the number of times a particular data, okay, occurs, okay, a particular observation appears in a collection, that is in a data, is what we call frequency. Understood? So what is frequency? The number of times a particular observation appears in the data. Okay, and this frequency can be represented using tally mark in smaller classes. Okay, so this is a second way of representing data. And in another way, in the third way, you can also represent, okay, the data in another way. That is, suppose I am converting this data in class interval form. Class interval form. Okay, that is between 0 to 10. Okay, the marks scored by some students, and their mark falls between 0 to 10. There may be 10 students. Okay, and 10 to 20. Okay, then 20 to 30, 30 to 40 and 40 to 50. Okay, so here you can represent, okay, this number of students, okay, whose marks falls in different class intervals. Okay, so in the first 2 cases, this data is what we call ungrouped data. I haven't done anything with regard to that data in its original form. Here what I did, that ungrouped data are converted into different class intervals. So this become grouped frequency distribution. You can represent the same data in another way also. Okay, the marks can be divided in different class intervals in this way also. 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. Okay, so how these two are different? Okay, how this first one is differ from the second case? Okay, see, suppose I am taking the first case. Okay, here in the first class interval, that is 0 to 10, in the class interval 0 to 10, okay, this 0 is what we call lower limit and 10 is what we call upper limit. Okay, and in the second class interval, this lower limit and in the first class interval upper limit both are same. Okay, and in the third class interval, the upper limit of the second class interval, okay, and the lower limit of the third class interval are the same. So this type of frequency distribution is what we call continuous frequency distribution. Okay, in the second case what we have, that is there are 25 marks scored by 7 students, okay, then 50 marks scored by 5 students. Likewise, see here this data you can see frequency and observations are there, and but this is what we call discrete frequency distribution. If the data are converted into different class interval, then it become grouped frequency distribution. And particularly in this this is what we call continuous frequency distribution. Why? Because the upper limit of the first class and the lower limit of the second class are the same. So this is continuous and this is discrete. So in this type, that is 0 to 10, 10 to 20, that is continuous class interval, this lower limit and the upper limit of the second class interval are the same. So this 10 belongs to the second class interval. Okay, and in this case 1 to 10, here the 11 and 20, because here the upper limit and the lower limit of the second class are both are different. So in this type of distribution is what we call inclusive form, because the mark 1 and mark 10 are both inside that class interval. Okay, second class interval start from 11 onwards. Okay, that means this type is what we call inclusive frequency distribution or inclusive form. But here what happened, this mark 10 belongs to the second, that is upper limit being the lower limit are the same. That means in continuous frequency distribution, okay, this upper limit belongs to the next class interval. Likewise, here the 10 to 20, 20 to 30, so this 20 belongs to the third. Okay, that means in order to include this, the number of students who scored 50 marks, you have to create one more class interval, 50 to 60. Understood? Because this 50 does not belongs to this fifth class interval. This will belongs to only this upper limit falls in the next class interval only. Understood? So this type of frequency distribution, that means here being the upper limit and lower limit are the same, this is what we call exclusive form or continuous form. Okay, so the problems which we are dealing with in this lesson, this is the very important point. Before you apply the formula, you make sure that the class intervals are continuous form. That means upper limit and lower limit. Okay, the first class and second class or the second class with the third class must be same or exclusive form. Understood? So how can we convert this inclusive form, that means discontinuous form, into continuous? That is very, very important. That means that here we have to familiar with a new term, that is adjustment factor. and the adjustment factor is nothing but, okay, here the upper limit of the first class is 10 and the lower limit is 11. Understood? So take their difference. 11 minus 10 is 1. Okay, and 1 divided by 2, that is adjustment factor. In order to get the adjustment factor, okay, take the half of the difference between the upper limit and lower limit. Okay, that means you have to subtract smaller number from the biggest number. Okay, that means 11 minus 10 divided by 2, half of by 2, that is 1 by 2, that is 0.5. This 0.5 should be subtracted from the lower limit of each class interval of this inclusive form or discontinuous form, and you have to add that adjustment factor with the upper limits of each class interval. Let us see what is going to happen for this inclusive form. If you are adding and subtracting the adjustment factor, okay, that means first we have to subtract the adjustment factor 0.5, okay, from each class interval, lower limit of each class interval. That is, now 1 become 1 minus 0.5, that is 0.5, 0.5, and if you are adding the adjustment factor 0.5 with the 10, it become 10.5. Okay, now I am going to subtract 0.5 from 11, so this become 10.5, and I am adding adjustment factor with the 20.5. Likewise, you will have 20.5 and 30.5 by adding by subtracting 0.5 from 31, 30.5, 40.5, okay, 40.5 and 50.5. Understood? That means, children, listen. Here now the upper limit and lower limit are the same. That means we have converted discontinuous form into a continuous form, or inclusive form into exclusive form. Okay, this is very, very important. If you are converting that means this inclusive form into continuous form or exclusive form, now this is what we call actual class limit. This is actual class. This is the class intervals that we have in the question. Okay, but we have seen that they are not in continuous form, and after adding and subtracting the adjustment factor, we have got continuous form. We converted into continuous form. So this is what we call actual class limit. That is actual class limit of lower limits and the upper limits. Okay, so suppose we have a continuous class interval. Okay, that means for making that example simple, so 10 to 20, 20 to 30, definitely upper limit and lower limit are same, so this is continuous form. Okay, so in the first class interval 0 and 10, okay, 10 minus 0, that is 10. This is what we call the class width. Okay, so in order to get class width, okay, subtraction, okay, take the difference of upper limit and the lower limit of each class interval. Okay, in the second class interval, if you take 20 minus 10, 10, so the class width will be same. Okay, all the problems which we are discussing in this year, okay, all the class width of each class interval will be same. Okay, 20 to 10, 30 to 20. Okay, so this is class width. That means the difference between the upper limit and lower limit of each class interval will give you the class width. Okay, and the next term, this all we have discussed in the last year. So in order to start the problems, I just revise what we have discussed in the last year. Okay, so I hope the class width is clear. What is actual class width, class limit, and how can we convert that discontinuous form into continuous form? That is very, very important. That is by finding the adjustment factor and subtracting and adding with the lower limit and upper limit respectively, you can convert this discontinuous form into continuous form. Okay, and next very important point is class mark. What is class mark? Okay, so look at this continuous class interval, that is we have 3 class intervals, 0 to 10, 10 to 20 and 20 to 30. Here take the first class interval 0 and 10. Okay, if you add upper limit plus lower limit divided by 2, this will give you class mark. Okay, don't confuse with the class width. We are usually representing by H, letter H. Here class mark or mid value. Okay, what is the mid value of the first class interval? Okay, upper limit 0 plus lower limit 10 by 2, that is 10 by 2 is 5, 0 plus 10 is 10. So 5 is the mid value of the first class interval. Okay, and in the second class interval 10 plus 20, 30 by 2, 15. Then 20 plus 30, 50 by 2, 25. So find out class mark or mid value by adding upper limit, okay, plus lower limit by 2. So you will get the another column, that means you have class interval, then frequency definitely you will have, then find out the mid value. Then only we can apply the formula in order to get different values, okay, according to the question. So find out class mark or mid value by adding upper limit, okay, plus lower limit by 2. So you will get the another column, that means you have class interval, then frequency definitely you will have, then find out the mid value. Then only we can apply the formula in order to get different values, okay, according to the question. These are the very basic terms which we have discussed in the last year. In the 9th standard, we have discussed mean, median, mode of ungrouped data. In this year, we are going to discuss mean, median, mode. That is what we call the 3 measures of center tendencies, okay, of grouped data or discrete frequency distribution table. Okay, that means grouped data means continuous. Discrete means that is the marks, for example, and its corresponding frequency. Okay, that data are not in class interval form. That is what we call discrete frequency distribution, but it has frequency each observation having the frequency, but that data are not in class interval form. That is what we call discrete frequency distribution table. And if the data are divided or converted into different class intervals, then it is called grouped data or continuous frequency distribution. Understood? Okay. So first we are going to discuss about the mean of grouped frequency distribution as well as discrete frequency distribution. Okay, so in the first example, I have given the marks scored by a student in 5 different subjects. Okay, there that I haven't mentioned anything about its frequency. I just have given 5 marks. Okay, that is 42, 43, 45, 44 likewise. Okay. See, so in order to get the arithmetic mean or simply mean, and we are representing this with x bar. Okay, so x bar of this data. Okay, here the variable x denotes the marks of a student in different subject in an examination. Okay, so this can be expressed as x1, okay, different values of x, okay, x2, x3, x4, x5, okay, or in short xi's. Xi's are nothing but different values of x. Okay, here x is nothing but the mark. Okay, so in order to get the arithmetic mean of these observations, just sum and divided by sum of the observations divided by total number of observations. Okay, so here the sum of the observation means 42 plus 43 plus 45 plus 44 plus 42 divided by number of observation, number of subjects. Okay, here 1, 2, 3, 4, 5. So 5. Okay, or x bar is equal to sum of the observation. So in order to express the sum, the summation, we have a Greek letter to represent, and that is what we call sigma. Sigma means summation. Sigma, summation. Okay, so sigma xi, what is the meaning of sigma xi? Xi denotes the different values of x, so x1, x2 up to xy. Okay, divided by n. N means number of observation. This is arithmetic mean of this data. Sum of the observation divided by number of observations. Okay, and in the second case, how I expressed, that is for discrete case. That is, we have mark or particular mark and number of students, frequency also there. Okay, so if we have that type of representation, okay, that is, suppose for another example I am taking to make the calculation easy, that is 20, there are 7 students, okay, 15 marks, okay, 5 students, okay, so this is marks and this is frequency, number of students, okay, and 5 marks scored by 6 students, okay, then 12 marks scored by 7 students. Okay, so here this is discrete type. Okay, that means in order to get its arithmetic mean, what is the formula? That is, so in all cases we are representing the arithmetic mean or simply mean by x bar. Okay, so here we have different methods to compute arithmetic mean for discrete as well as continuous frequency distribution. Okay, and the first method is what we call direct method, and the second method is assumed mean method, assumed mean, okay, or shortcut method, both are the same. So first I am going to explain how this arithmetic mean of this problem by direct method can be found. Okay, that means if the observations are very simple, that is very less number, okay, small number, it would be better to use direct method rather than assumed mean method. That is very important point, children. Okay, so here 20, 15, 5, 12, that is not that much big number, so you can definitely apply direct method. Okay, so here the observations are very small numbers. Okay, so by direct method, okay, here we need one more column, we have to prepare one more column, okay, and there we have to, so these marks are representing by xi, okay, here fi, here I start from 1 to 4, 1, x1, x2, x3, x4. Okay, if we have one more mark, that is 10 marks scored by what is it, 8 students. So here I ranges from 1 to 5, okay, 5 marks, and number of students who scored exactly 20 marks. Okay, that is the meaning of frequency. Okay, so in the third column you have to get the product of xi into fi. So the third column xi fi column or fi xi, that doesn't matter, because multiplication is commutative, so xi into fi or fi into xi doesn't matter. So you have to multiply xi, each xi with fi, its corresponding frequency. 20 into 7, 140, here you will get 75, here 5 6s are 30, here you will get 84, here 80. Okay, that is in the third column xi fi in the case of discrete frequency distribution. Okay, and here you have to make another row. Okay, here each mark and its corresponding frequency. Okay, now we have their product column, that is xi fi. So in the last row, better to write total. Okay, total is find out the sum of the frequencies. Okay, that is again summation comes. So sigma fi is nothing but sum of the frequencies, that is 12, 7 plus 5, 12, and 6, 18, then 25 plus 8, that is 33. Okay, and here also you have to find out sigma xi fi. What is the meaning of sigma xi fi? Sum of the product of xi and fi. That means you have to add these values. Okay, and here comes, okay, 4, and in tens place here 16, 19, 26, and 30, and 3 carries 404. Okay, sum of this third column will give you sigma xi fi. Okay, and in order to calculate the arithmetic mean or mean of discrete frequency distribution, this is the formula by direct method. Okay, that is sigma xi fi divided by sigma fi. Here in the first example, we have divided sum of the observations with the total number of observations. But here in this discrete case, discrete frequency distribution, we have to divide with the sum of the frequencies. Okay. So here what we have got after adding xi fi, 404 divided by sigma fi. This is sigma fi 33. Is it clear, children? This is the way you can find out the arithmetic mean of discrete frequency. You have to simplify, definitely you have to simplify this 404 divided by 33. This is just for an example. 33, then 7 on subtraction, then bring down this 4. So you will have 2, that is 66. Okay, then 8, then decimal. Okay, again 2 likewise, that is 12.2 nearly. Okay, so this is the average of mark. This is regarding the mark. The first column indicates the mark. So its average is nearly 12.2 something. Anyhow, sum of the observations divided by number of observations for the first case, ungrouped data. For grouped discrete frequency distribution table, sigma fi xi divided by sigma fi by direct method. Okay, this sigma fi also can be expressed using the letter capital N. So this is the formula for x bar can be also be written as sigma xi fi divided by capital N, or okay, sigma fi is also same as capital N, that is denotes, capital N denotes sum of the frequencies. Okay, this is the way you can find out arithmetic mean by direct method. Okay, that is if the observations are very small number, this would be better. The second method is assumed mean method. If the xis means that the observations, different observations is little bit large quantities, large numbers. Okay, that finding arithmetic mean by direct method, but that means we have to apply the, what is the formula by a direct method, sigma xi fi, that is we have to get the product and get the sum divided by total number of that is sum of the frequencies. Okay, so if the big values, it would be difficult. So in that case we are applying this assumed mean method. That means we have to assume one among this xis as the mean and let it be a, small letter a. Assume one observation from this xi column, first column. Let it be a, small letter a or capital letter A, doesn't matter. That is A denotes assumed mean. A denotes assumed mean. We are assuming that is the mean for that observation. Okay, that means this is the example. I am selecting one from this exercise. So in order to get that, make our calculation easy, if it would be better to select one from the middle, that A must be maybe from the middle of the observation. That would be better. almost middle, okay, not compulsory, okay. So after assuming that 72 or 1 from xi, middle value of xi as assumed mean, next column, that means you have to prepare one column, and that is you have to take deviation, that is represented by di column. Di, you will get di column, just take the difference of that xi minus a, each xi starting from the first minus a, xi minus a, that is in the third column. You have to take deviations from this assumed mean, okay, that is xi minus a is di, okay, this is in the third column, okay. So we are going to find out the difference between each xi and its from its arithmetic mean, okay. So here xi is 67, okay, 67 minus a, here a equal to 72, assumed mean, we have selected assumed mean as 72. Okay, so here the first x is 67. So 67 minus a, 72, that is 5, negative 5. You have to consider the sign also. Subtraction is not commutative. xi minus a. So here comes negative sign. Here 70 minus 72, that is negative 2. 72 minus 72, in the third column, xi takes the value of its arbitrary mean, that is a, okay, that is 0. Then 73 minus 72, now you will get positive values 1 and positive 3. So how to prepare the third column is clear, that is di column, xi minus a is nothing but 1 from the middle, almost the middle from these observations, xi, 1 from xi column. Okay, and in the fourth column, here comes fi into di. We can't make any change in the frequency column, that is second column, okay. So we are just converting this xi column into di column by subtracting xi minus a, okay, and in the fourth column get their product, that is each di and fi into di. Okay, so fi, if you are taking first frequency, you have to take the first deviation. Okay, that is 4 into minus 5, minus 20, minus 6, 3 into minus 2, 2 into 0, 0, 2 ones are 2, and 1 threes are 3. So this is the preparation of the table in order to apply this assumed mean method. Okay, and here comes the formula to compute the arithmetic mean by assumed mean method, that is x bar is equal to a plus sigma fi di divided by sigma fi. Sigma fi is nothing but sum of the frequencies. Okay, here you can write sigma fi. Okay, you can add 4 plus 3, 7, 9 and 11, 12. Okay, then comes sigma fi di, sigma fi di. We have fi di's are here. Okay, negative 20, negative 6, negative 26. Here the positive value is 2 plus 3, 5. Here all the negative together, negative 26 comes. Here 5. Okay, so here negative 26 plus 5 is negative 21. Negative 21, sum of fi di. Now we can substitute in this formula, that is a we have chosen as 72 plus sigma fi di negative 21 divided by 12, sum of the frequencies. Okay, so 12. Okay, here 7, 8, 12. Okay, so we are going to get their final answer. 72 plus negative 21. 21 divided by 12. Okay, 12 one time, 12, 9 and 90, 12 into 7, okay, 84, then 6, 60, 12 5s are 60, but negative sign, okay. So, negative 1.75, okay. So, we are going to subtract, that is 72 minus 1.75, okay, 70.25. This arithmetic mean will be very close to this arbitrary mean, that is a, small letter a, that is assumed mean. We have assumed that 72 may be the mean. Okay, so the final answer, that is we assumed, that is not the actual mean. Okay, in order to make our calculation easy, okay, we have take the deviation of each observation from this assumed mean, and we have formed that di column and get the product, and we can apply the formula a plus sigma fi di divided by sigma fi. This is the method which we are using if the xi's are large values. Rather than the direct method, this would be the better method. Is it clear? Yes. Now we are moving to how to compute. Here we have discussed, we have taken the discrete case. How this can be work on continuous frequency distribution. It's very quite simple, children. If you get this idea very clear, you can easily apply this formula even if that frequency distribution is continuous. That is, if the observations are divided in class interval form also, you can very easily apply this method. I will explain that also. Okay, that means if the frequency distribution is continuous. Okay, that means I will just write the example 0 to 10, 10 to 20, 20 to 30 and 30 to 40, just for an example. How this formula can be applied for continuous class interval form. Okay, so in the beginning I told you have to make sure that this class intervals are in continuous, that is upper limit and lower limit must be same. Okay, so 10, 10, 20, 20, 30, 30, that is this is continuous. Okay, so this is class interval. Okay, and suppose these are the frequencies 5, 7, then 3 and 10 frequencies of each class interval. So children, you have to find out the class mark or mid x, mid value. We can't do anything with this class interval form. In order to apply that formula, okay, you have to find out the class mark or mid value, the number which lies exactly in the middle of each class intervals. How that can be found? Mid class mark is equal to upper limit, lower limit plus upper limit divided by 2, 0 plus 10, 10 divided by 2. So that can be expressed as xi. Here comes xi. Okay, from the class interval form, find out class mark or mid value. That is 5. Here 10 plus 20, 30 by 2, 15. Okay, then 50 by 2, 25. 70 by 2, 35. Then all the remaining procedures are same. We have one more method to find out the arithmetic mean for continuous frequency distribution. Okay, that is step deviation method. But that method is deleted from our portion for this year. Okay, so now we are moving to the second center tendency, that is mode. Okay, in the last year we have learned what is mode, children. Mode is for ungrouped data. Okay, it is the value which occurs most often. To find out the mode of these observations. Okay. Okay, so what is mode, children? Mode is the observation which occurs most often. Okay, that means we have to number of times that a particular observation occurs. That means we have to find out its frequency. Number of times means frequency. So here we are talking about 0, 1, 2, 3. Here in this observation, in this data, how many times 3 occurs? 0 occurs only one time, 3 2 times, 1 this 1 how many times? 3 times, 1 2 3, and 2 2 times, and 3 2 times. Okay, so here excise his frequency. The maximum frequency comes for 1, maximum frequency. Find out the maximum value in the frequency column. Okay, that is for the observation 1. So in this problem, the mode is 1 because 1 comes most often. Maximum frequency goes for 1. So 1 is the mode of this observation, this given data. Okay, so this is what about mode. Okay, so mode can be, there is no problem about it can be for 2 observations, can occur in maximum number of times, that is 3 times. Okay, if we have 2 also occurring in 3 times. Okay, so you have to write mode equal to 1 and here 2. In such cases we have multimodal. Okay, so that also possible, but for continuous frequency distribution, okay, we are discussing only single mode. Okay, in 10th standard all the problems, if you are asking find out the mode, you will get only one mode for one collection of observation data. Okay, next we are going to discuss the mode for continuous frequency distribution. Okay, for that find out the class interval having the maximum frequency. Okay, so from the frequency column, here 8 is the maximum value among the frequencies. So its corresponding class interval is 3 to 5. Okay, and select this as the model class. Okay, so that is the first step. Locate the model class, and you can find out the mode by using this formula: L plus F1 minus F0 divided by 2F1 minus F0 minus F2. This is a single fraction into H. And this H is nothing but the size of the class interval, that is class width. Okay, in the beginning of this video I told what is class width, and that can be represented by H, that is upper limit minus lower limit. Okay, we are dealing only the problems having the same class widths in this year. Okay, so 5 minus 3 is 2. So here in this problem, model class is 3 to 5, the class having maximum frequency. Okay, that is 8. And what are the other things? That what is this? L denotes the lower limit of the class, model class. Here that is 3. In the class interval 3 to 5, the lower limit is 3. Okay, and what is F1? F1 is the frequency of the model class. Frequency, F1 is frequency of the model class. Okay, and F0 is nothing but the frequency of the class preceding the model class. Okay, which before. Okay, that is 7. Frequency of the class preceding. Okay, class frequency of preceding. Okay, the model class, that is here, that is 7. Okay, this is F0, and F2 is the frequency of the class just comes after the model class. Okay, here that is, this is F2, that is 2. Okay, and H is the class width or the size, that is 2, that is 3, 5 minus 3, that is 2 is H. Now we can easily find out the mode of this continuous frequency distribution problem, that is L minus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. That is the formula to find out the mode. So in order to find out the mode of a continuous frequency distribution, you can apply this formula, that is mod is equal to L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into H. Okay, median is one of the another center tendency, and you have learned how to find out the median for ungrouped frequency distribution in 9th standard. That is very simply you can arrange the observation in either the ascending order or descending order, and depends on the number of observation. If the number is odd, you can easily find out by n plus 1 by 2th observation. Okay, if n is even, that is half of n by 2th observation plus n by 2 plus 1th observation. That we have learned. That is, if n is odd, n plus 1 by 2th observation. That is how to calculate the median of this. That is 7, 8, 11, 5, okay, and 3. Okay, so here 1, 2, 3, 4, 5. This is an odd. Anyhow, you have to arrange this in ascending order, that is, or descending order. So 3, 5, 7, 8, 11. So here n is equal to, what is n? 5. So 5 plus 1, that is n plus 1, that is 5 plus 1, 6 by 2, that is 3. So third observation. So 1, 2. So 7 is the median. Okay, so you can easily find out the mid value if the number of observation is odd. But if it is even, if we have only 4 observation, how to find out its median? Okay, so we have to find out n by 2th observation, that is 4 by 2 second observation plus n by 2 plus 1 third observation by 2, that is second and third, that is 5 plus 7 by 2. That is, if n is even, okay, if n is even, median is equal to half of n by 2th term or observation plus n by 2 plus 1th observation or term. So that is how we can calculate this. That is, median is equal to 12 by 2, that is 6. That is 6 is the median of this given observation. Okay, so median always lies exactly in the midway of the given observation. Now we are going to discuss the median for discrete frequency distribution table. That means here the observations are not in the class interval form, okay, but each observation having its frequency. How to calculate median for such frequency distribution or discrete frequency distribution? Okay, that means here comes the example. Here the 20 xi, okay, here the frequencies. Okay, so in this case you have to, that is for discrete frequency distribution, in order to find out median, you have to first find out the cumulative frequency. Cumulative, what is cumulative frequency? In order to form the cumulative frequency column or CF column, okay, the cumulative frequency of the first observation, okay, it's the frequency itself. That is, that for 20 is the first observation, and its frequency is given as 6, so its cumulative frequency also 6. And the cumulative frequency of the second observation, that is 25, is the sum of the frequencies of the first and the second frequency. Okay, up to this, that is 26. You just add, and sum of this first 3, that will give you third cumulative frequency, that is 26 plus 24, that is 50. Okay, likewise you can get the cumulative frequency of each observation, okay, and 50 and this 28, 78, because we added up to this in order to get its CF, so you have to add 15 with the 78. Okay, that is, you will have a 93. Okay, so it will be 97. Up to this you have got the sum as 93. You have to add its frequency also, that will give you CF of the observation 38. Okay, so 97 plus 2, 99, and 99 up to this is 99, sum of the frequencies up to this is 99, including this will give you CF of the last observation, that is 100. I hope this is clear how to find out the CF, okay, sum of the frequencies up to that observation, that will give you its corresponding CF. Okay, and here we have seen that the sum of the frequency is an even number. So, the median of an even number, we have seen that it is the half of n by 2 observation plus n by 2 plus 1th observation. Understood? What is its meaning, children? Here you have to write 26 times, 25 20 times, okay, 28 24 times. That is the number this frequency indicates. Okay, so here n by 2 is 50. So, since here n is equal to, or capital N, sum of the frequency sigma Fi, that is 100, being it is an even number. Okay, so the median is equal to half of n by 2th observation plus n by 2 plus 1th observation. Okay, so here n is 100 by 2, that is 50. That is 50th observation, that is 28. Okay, so we have written 28 24 times and 25 20 times. So, the half of the observation we have taken. Okay, so the next 51th term or 51th observation, that is how that 51 comes, that is n by 2 plus 1, n by 2 is 50. So, that will be 29. Okay, so 51th observation will be 29. So, what will be its median? That means median is equal to, since n is equal to even number, that is 28 plus 29 by 2. Is it clear, children? That is 7, 1 carries 57 divided by 2. Okay, and when you divide you will get 28.5. This is the median of this discrete frequency distribution table. That idea is clear, children. If you write 26 times, you have to write 25. So, 50th observation will be 28. So, 51th observation will be 29 and take its average half. That will give you the median for even numbers, because we have 100 as the even number. So, 28.5. Okay. Next we are going to discuss about how to compute median of continuous frequency distribution. We already have seen that how that can be, median can be easily found if the number of observation, that is for ungrouped data, for discrete frequency distribution, and finally when it is in the form class interval. Okay, that means in the third column you have to find out the cumulative frequency. Here we have class interval, okay, here frequency, and you have to form cumulative frequency for each class interval. Okay, yes, and I already told what is cumulative frequency. Cumulative frequency of the first class interval is always its original frequency itself, that is 7. Okay, here the frequency of the first class interval is 7. So, in order to get the CF4, CF means cumulative frequency, for the second class interval, sum of the frequencies of first two, that is up to that second class interval, that is 7 plus 13, that is 20. Okay, then what will be the cumulative frequency of the third class? That means you have to add these 3 frequencies. We already added 2 frequencies and we got 20, 20 plus 5, 25. Okay, and this will be 33, that is 25 plus 8, that is 33. Is it clear, children? Then after finding this cumulative frequency, okay, find out sigma Fi, or that can be represented also by capital N. Okay, so sigma Fi is equal to, that is here 20, that is this will be, that the sum of the frequency is 33, this is equal to capital N. Okay, find n by 2, okay, capital N by 2. Capital N by 2 will be, that is 33 divided by 2. that is 1, and in 13 6 times, okay, 12 and 16.5. And in the cumulative frequency, okay, and find out the cumulative frequency just greater than n by 2. N by 2 we have seen 16.5, just greater than. This 25, 33 both are greater than 16.5 n by 2, but just greater than means 20. Okay, 20 is very close to n by 2, that is 16.5. Okay, and its corresponding class interval is the median class. So, in continuous frequency distribution, the first thing is locate the median class. Okay, the class, okay, which just having the cumulative frequency just greater than n by 2, and n by 2 is nothing but the half of sum of the frequency. Okay, so this is the median class, and after that you can easily find out this median by substituting the values in this formula. Median is equal to L plus n by 2 minus CF divided by F into H. H is always class size, that means upper limit minus lower limit. Okay, of each class interval being same. So 20 minus 10 is H. Okay, then what is L? Surely that L is lower limit of the median class. Okay, and n by 2, that is small n by 2 or capital N by 2 denotes this number, that is 16.5. Here the CF is cumulative frequency of the class preceding the median class. Okay, that means the class having cumulative frequency just above its median class. Okay, here that is 7. Okay, preceding means before. And F is, of course, that is the frequency of the median class. Here that is 13. Okay, we have highlighted the median class as 10, 20, frequency is 13 and CF is 20. So CF will be preceding class. Okay, cumulative frequency of the preceding class, and H, of course, the class size. I hope this idea is clear, children. That is, it is quite simple. Find out sigma Fi, okay, and take its half. That will help you to locate the median class. Okay, so that is the cumulative frequency just greater than this n by 2, and its corresponding class interval will be the median class.